All right, so this is pretty straightforward. Section 9.2, we did the hypothesis test for populations, okay, when we knew the population standard deviation. 9.3, we did the hypothesis test when we had the sample standard deviation, and now this is proportion. Okay, so your formulas for proportion, the steps are not going to change, just kind of reading through this. You're going to use, you can still use the p-value, and now we're using these calculations. So for the z-value, you're doing p hat minus p over the standard deviation of p hat, where that standard deviation of p hat now is this calculation. So really, in each section, the calculation for standard deviation is different. So you have to figure out how it's given. Proportion is fairly straightforward because it's going to be a percent, or it's going to be given to you like 50 out of 100 or something like that. As was the case in chapter 7 and 8 for for proportions, normal distribution is used. I don't have my normal pad, so this is a little bit more difficult to write on, and it's very sensitive. There we go. Okay, so we're going to be using normal distribution, and we will be using z. Okay, so the only time we're using t is when we have that sample standard deviation. Otherwise, we're using z. So we're going to dive right in and do some homework or some examples. Okay, so example 7.1, a family is referred to as food insecure when the family is uncertain of having or unable to acquire enough food to meet the needs of all their members because they had insufficient money or other resources for food. In 2018, the U.S. Department of Agriculture found, here we go, that 11.1% of U.S. households were food insecure at some point during 2018. A nonprofit believes that the proportion of food insecure families has actually increased since 2018. A recent sample found 32 out of 200 families reported being food insecure. Do the sample data support the nonprofit's belief that the proportion of food insecure families has increased since 2018? Use p-value and a significance of 5%. Okay, so there's all of our information. Now, this doesn't outright come out as a proportion, but it will, well, it does with the 11.1%, right? So we can start off with that. So you have the population proportion of all U.S. households is 11.1%. So that's your P, 0.111. Okay, so that should signal to you that that is a proportion. If your P is 0.111, your Q is going to be 889. Yeah. Gotta pull my calculator up. Okay, so 1 minus 0.11. And that'll give you 0.889. Okay, so we have our P and our Q, and then in the sample, we just have the 32 out of 200 families being food insecure. So it doesn't give you a standard deviation or anything. Okay, so that should clue you in, okay, now this is proportion. Okay, so this means that that is P hat. So P hat, that's your sample proportion, is 32 out of 200. That is going to be 16, yeah, 0.16. Okay, which means our sample size then, if it's 32 out of 200, that gives us a sample size of 200. Okay, and the last thing we have is we have a significance level, 0.05. Okay, so we have all of the information. We notice that it's a proportion, so that means we're using a z. Then we want to do our hypotheses. Okay, so the last sentence says, do the sample data support the nonprofit's belief that the proportion of food insecure families has increased since 2018. So that means that's the alternative hypothesis. Okay, the alternative hypothesis is that P is actually greater than the 0.111. Okay, that last sentence gives us our alternative. The null hypothesis then is just the opposite, that P is less than or equal to 0.111. All right, then the critical value, so the z value. Okay, we have a significance level of 0.05. P is greater, so the alternative says it's greater, so that means we're doing a right tail because it's pointing to the right. Okay, so that means over here on the right side, we have an area of 0.05. We want to find the z value that will correspond to that. So if I go to my calculator, second distribution, inverse norm, so number 3. Area, we'll try 0.05. Mean and standard deviation, 0 and 1. We get negative 1.645. It's on the right side of 0, though, so we're going to make it a positive 1.645. So that is going to be our critical value. Okay, so our critical value, we will reject the null hypothesis if we get a z greater than 1.645. Okay, because this right here, shaded area, that is our rejection region. Okay, now we're going to calculate the test statistic, which means we need those 2 calculations from the beginning. So the first is the standard deviation of p hat, okay, which is the square root of p times q, so 0.111 times 0.889 over the sample size, which was 200. So we'll put that in. So we go square root, and I'm going to go parentheses, 0.111 times 0.889. Close that numerator, divided by 200, keeping it all under the square root. It's going to give me 0.0222. So I find that standard deviation, and then I do the z-score, which is p hat minus p. So p hat was 0.16, p 0.111. Okay, over the standard deviation that we just found, 0.0222. Okay, so 0.16 minus 0.111 divided by 0.0222. We're going to get 2.2072. So there's our value. That's going to be about right there in our rejection region. So we can clearly see that it's in our rejection region. We have 2.2 is greater than 1.645. So we will reject the null. Now it did ask for the p-value, so we have to find the p-value there. So for the p-value, you're just finding that probability back to chapter 6. Okay, you're just going normal CDF. And you're just finding, so if this is 2.2, like right here, you're just finding this area shaded in purple here. If it will let me shade, there we go. So that's going to be pretty small. We're going to go normal CDF. We'll do 2.2072 for the lower limit. Then we'll do a positive 99 for the upper limit. and that will give you 0.0136. Yes, on either side. So the upper limit would be a positive 99 if we're doing an upper limit to the right. If we're going to the left, it's going to be negative 99. Okay, so we get a p-value of 0.0136, which is less than 0.05. So again, we say reject the null, reject the hypothesis that, what is this? That 11.1% of U.S. households are food insecure, less than or equal to, it is likely that more of them are. All right, let's do another example. Okay, last year, the U.S. Census Bureau found that 8.5% of U.S. population did not have health insurance. A public policy researcher would like to determine if the percent of uninsured Americans has changed since last year. The researcher gathered a random sample of 2,000 Americans, found that 131 people from the sample did not have health insurance. If alpha is 0.001, do sample data support the notion that the percentage of uninsured Americans has changed since last year? Okay, so what we have here is we have 8.5% of the population does not have health insurance. That is the proportion. So that's your P, 0.085. Yes. That is your proportion, yes. So Q will be 1 minus 0.085, which will give you 0.915. Okay, so we have that. And then let's see here. The researcher gathered a sample, so that your sample size is 2,000. In that sample, 131 do not have health insurance, so that is P hat. P hat is the sample proportion. So that's 131 out of 2,000. That is 0.0655. Very good. .0655. And then our significance level, 0.001. Very small significance level there. 0.001. Okay. So, hypotheses. The question says, do the sample data support the notion that the percentage has changed? So no increase or decrease, that's, which one is that? Equal and not equal. So the alternative is that P is not equal to 0.085, which means the null is that P is equal to 0.085. This is proportion, so we're using a Z. Now, equal and not equal means that I have a two-tail test. So I have a two-tail. If my significance level is 0.001, I need to take that 0.001 and divide it by 2. So that would be 0.000. Yeah, 3 zeros and then 5. So 4 decimal places. 1, 2, 3, 4. So 0.0005 on either side here. So this is going to be pretty far over. So 0.0005 on the left, 0.0005 on the right. These will be our rejection regions. This tablet is very annoying. Here we go. There we go. Okay, so let's find that z value. So I'm going to go inverse norm. And then I'm going to have area 0.0005. That's going to give me negative 3.2905. So over on the left, you have negative 3.2905. And then on the right, it's just going to be positive 3.2905. So my rejection region will be to the left of our negative z and to the right of our positive. And then our non-rejection region is in between. Okay, so our decision will reject if we get a z less than negative 3.2905 or greater than. All right, so we'll calculate the test statistic. So we first do the standard deviation of p hat. So that'll be p times q, so we got 0.085 times 0.915 over our sample size, 2,000. So square root 0.085 times 0.915 over 2,000. We're going to get there 0.0062. Then we're going to do our z value, which is going to be p hat, which we found was 0.0655, minus p, which is 0.085, over 0.0062. Okay, so 0.0655 minus 0.085, and then divide by 0.0062. It's like it says negative 3.1452. That's close. Okay, so our test statistic, negative 3.1452, which is like right there, just outside of the rejection region. Okay, which means that this is, so negative 3.1452 is actually greater than negative 3.2905. So we will fail to reject. Okay, if the significance level was slightly higher, we would probably reject that. But because it was such a small significance level, we do fail to reject for that one. And then the p-value would just be for that one, since it's on the left side of 0. You would have a, you would go normal CDF with a lower limit of negative 99, and then your upper limit, that negative 3.1452. So normal CDF, negative 99, negative 3.1452. All right, so that's 8.3 times 10 to the negative 4, which means this goes 1, 2, 3, 4. So 0.00083, that's your p. Okay, you have one more example. Just kidding. I thought you had one more example. I have one more on here. I'm gonna let you guys do it on your own. So let me pull it on here. You don't have to write the whole thing out, just like the information that you need. There you go. Okay, so a college recently advertised that 92% of its students graduate debt-free. Student advocacy organization thinks the college claim is unlikely. The organization collected a random sample of 1,300 recent graduates from the college and found 93.5% of its sample graduated without any student debt. Significance level 0.005. Employ the critical value method to test the hypothesis that the proportion of all students from this college that graduate debt-free is different than 92%. So go ahead and try that out. Okay, let's go ahead and take a look at this. So we have here a p-value of 0.92, which means our q is 0.08. We have, let's see, sample size of 1,300. And we have 93.5%, so that is going to be our p-hat, 0.935. Okay, so our null hypothesis and our alternative hypothesis. So we have here, we want to test the proportion, see if it's different than 92%. 92%. So the alternative hypothesis is going to be P is not equal to 0.92. Good. And then the null is that it is equal to 0.92. Okay, so we have that. We have all of our information here. So let's find that critical value for 0.005. So since it's not equal, that's going to be a two-tailed test. So we're going to have to go 0.005 divided by 2, which is going to be what? Yeah, 0.0025. Okay. And very crooked there, but 0.0025 on either side here. And are we using Z or T? Z. Good. All right, so inverse norm, 0.0025, 0 and 1. That will give us negative 2.807 and positive 2.807. Okay, so our critical value, we say this is critical value Z, is 2 plus or minus 2.807. Okay, so let's find our test statistic now. So that we're going to first start by finding the standard deviation of p-hat. So we're going to go square root of 0.92 times 0.08 over 1,300. Let's see here. So square root 0.92 times 0.08, close that, over 1,300. That gives me 0.0075. Then I'm going to do my Z. So Z is going to be p-hat, which is 0.935, minus p, 0.92, over 0.0075. So 0.935 minus 0.92 over 0.0075, 2. Nice round number, yep. And that's about right here. And this is in our non-rejection region. So we will say fail to reject the null. Okay, which means that it is likely that 92% of graduates graduated debt-free. Now, if we wanted to do the p-value for that, we would just go normal CDF, lower 2, upper 99, 0.0228 would be the p-value. Yes. If it is on the right side of 0, I'm going to do go to positive 99. If it's on the left side, I'm going to start at negative 99 and stop on the other side. The p-value? Z, yeah, Z is usually 2 decimal places. Yeah. Remember, the test is multiple choice, so whatever's on the test. I haven't even looked at it, so. Yeah. Yeah. Yeah.